A Boeing 737 was only 500 feet above the ground. Inside the cockpit, everything seemed under control. But then, a sudden radio transmission shattered the vigilance.
325, you are not authorized to land here.
Trying to clarify the message, the captain reached for the radio switch on the control yoke, but accidentally pressed the autopilot disconnect button instead. In an instant, the Boeing 737 veered off its glide path and began a rapid descent. Chaos erupted inside the cockpit. The captain desperately attempted a go-around, but it was too late. The aircraft could no longer avoid ground impact. In those final moments, what exactly happened inside the cockpit? Let us step into the story of TNT Airways Flight 325N. On June 15, 2006, at Liège Airport in Belgium, a TNT Airways aircraft was being towed to the runway, preparing for its next journey. It was a cargo flight scheduled to depart from Liège, Belgium, fly to London Stansted Airport in the UK, and then continue on to Edinburgh, Scotland. The crew for this flight consisted of 2 members. The captain, 42 years old with 10 years of experience, had accumulated over 8,300 flight hours, of which around 4,000 were on the Boeing 737. His first officer, age 35 with 10 years of experience, had logged about 1,700 flight hours, almost all of them on the Boeing 737. At 4 a.m. local time, the 2 pilots met in the dispatch office to carry out their pre-departure preparations. They first reviewed the weather forecasts for both their destination and alternate airports. At first glance, conditions at London Stansted Airport appeared favorable. Light winds, visibility exceeding 10 kilometers, and only scattered clouds. Flying conditions seemed relatively mild. However, the forecast also mentioned the possibility of short-term variability. Visibility could temporarily drop to around 8 kilometers, with thicker cloud layers expected at about 1,000 feet. In addition, there was a 30% chance of further deterioration, including dense fog that could reduce visibility to just 4.5 kilometers, and solid cloud cover forming as low as 700 feet. According to British aviation standards, these conditions still fell within acceptable limits for a safe landing. As for the alternate airports, including East Midlands near Nottingham, Liverpool, and Birmingham, weather conditions there also appeared favorable. However, while reviewing the notices to airmen, the crew discovered that runway 05 at Stansted Airport was under maintenance. The instrument landing system had been shut down. This meant that any approach would have to rely on the radar-based non-precision landing system, a method far less accurate than ILS and one that demanded stricter weather conditions. Out of caution, the pilots decided to uplift an extra 2 tons of fuel, allowing for extended holding in case they needed to wait for weather to improve. After completing all pre-departure preparations, the crew confirmed a total fuel load of 7,500 kilograms. The pilots then headed to the aircraft to meet with the loadmaster and finalize the flight. Upon arrival, the captain reviewed the maintenance log. No abnormalities were reported. Together, the 2 pilots carried out the pre-flight checklist. All systems were functioning normally. There were no indications of any malfunction. At around 5 a.m., the first officer obtained takeoff clearance. Shortly afterward, the aircraft began taxiing toward runway 23 for departure. For this flight, the captain was designated as the pilot flying, while the first officer acted as the pilot monitoring, responsible for system checks and communication with air traffic control. At 5:12 a.m., the aircraft took off smoothly, officially beginning its journey to London Stansted Airport. Because this was a short-haul flight, the first officer quickly switched from the main communication frequency to obtain the latest weather update for their destination. The report indicated conditions were still fair, with visibility around 6 kilometers. After reviewing the situation, both pilots agreed to request a holding pattern over a waypoint known as Lolo, in order to monitor how the weather might develop and to assess possible alternate airports. The first officer submitted the holding request, which was approved by air traffic control, instructing the crew to circle at 6,000 feet above the Lolo waypoint. At 5:50, Flight 325N entered its holding pattern. Yet only a few minutes later, the first officer realized their fuel reserves would sustain holding for barely 35 minutes. More alarming still, weather at Stansted was not improving. It was continuing to deteriorate. This prompted the crew to begin formulating a diversion plan. Rather than risk a last-minute high-stakes decision, they attempted to contact the airline's operations control center via the ACARS system. Initially, no response came through. As a backup, the crew switched to radio communications on Stansted's airline dispatch frequency, requesting direct contact with operations control and advice on alternate airports. The airline responded quickly, recommending a diversion to East Midlands Airport. With fuel remaining below their planned reserve, the crew accepted the suggestion. Air traffic control requested the crew to advise in advance of any diversion plans in order to coordinate routing with East Midlands Airport. The first officer acknowledged the instruction and requested the latest weather reports for both East Midlands and Liverpool airports. A few minutes later, ATC provided the updated weather information. Conditions at East Midlands were also deteriorating. The aircraft would need to land on runway 09, with local visibility reduced to 2 kilometers in light mist. At 200 feet, there was a broken cloud layer, and at 300 feet, an additional thick layer. These were quite challenging operating conditions. Meanwhile, the weather at Liverpool Airport remained excellent, with visibility exceeding 10 kilometers and light winds. The two pilots reassessed their diversion options. Since there was no sign of improvement at Stansted, they decided to divert to East Midlands at the earliest opportunity. This proactive decision would not only save more fuel, but also preserve the flexibility to continue on to Liverpool in case landing at East Midlands became impossible. At 6:19 a.m., the first officer informed air traffic control that they had decided to divert and requested to use runway 27 instead of runway 09, because runway 27 was equipped with a Category 3 autoland system, a crucial factor if the weather deteriorated further. Shortly afterward, ATC confirmed that East Midlands Airport had indeed switched its primary runway to 27 due to reduced visibility, and instructed the crew to leave the holding pattern, climb to 10,000 feet, and proceed toward East Midlands as the diversion destination. However, ATC then issued a stern warning. Visibility at East Midlands was extremely poor, only 400 meters at the runway threshold, 650 meters at the midpoint, and just 900 meters at the far end. This indicated that the entire airport was blanketed in dense fog. Under such conditions, a Category 3 autoland was the only feasible landing option. Category 3 autoland, the most advanced automatic landing system available, requires an aircraft to be equipped with 2 independent autopilot systems, dual power sources, multiple hydraulic systems, and to meet highly stringent technical standards. In addition, pilots are required to hold a special certification for Category 3 instrument landing system approaches before they can perform such a landing. Both the aircraft and crew on this flight were fully qualified to carry out a Category 3 autoland, and runway 27 at East Midlands Airport was equipped with all the necessary facilities. However, one important detail is worth noting. This was the captain's first time executing such a complex procedure from the left-hand seat. According to TNT Airways regulations, only the captain is authorized to perform a Category 3 ILS landing. This meant that the first officer was solely responsible for monitoring the flight, a task which, during an autoland, demands extremely high concentration and precision. As the aircraft turned north, heading toward East Midlands Airport, the first problem appeared. The crew of Flight 325N had not made full preparations for this diversion. While holding in the pattern, the captain asked the first officer to retrieve the East Midlands approach chart. But searching for the chart took a considerable amount of time, causing a delay in preparing the approach. As a result, the entire approach checklist was completed more hastily than standard procedures. Just after the captain finished the checklist, the aircraft was handed over to London Air Traffic Control. ATC instructed the crew to turn right to heading 360 degrees and descend to 8,000 feet. Shortly after, the pilots were transferred to East Midlands Approach Control. The new controller directed them to turn to heading 005 degrees to line up for the ILS approach to runway 27. At the same time, the controller provided the latest weather information. Visibility at the runway threshold, 350 meters. Midpoint visibility, 700 meters. Far-end visibility, 400 meters. All of these conditions represented severe limitations for a safe landing. Flight 325N began to reduce speed. The pilots deployed the flaps and configured the aircraft for landing. ATC then instructed the crew to descend to 3,000 feet, reporting the local QNH setting at 1,012 hectopascals. They also confirmed that the Category 3 low visibility approach lighting system was fully operational. Shortly after, the crew were cleared to continue down to 2,000 feet and instructed to report once the local instrument landing system signal had been established. The first officer acknowledged the clearance. Soon, the Boeing 737 successfully intercepted the instrument landing system signal. The aircraft turned toward the runway, preparing for the final approach phase. After the crew reported the ILS localizer capture, they were cleared to continue descent along the glide slope and handed over to East Midlands Tower on frequency 124.0 MHz. In a standard Category 3 ILS autoland, the approach mode must first be armed, followed by engaging both autopilot channels. The captain executed this sequence flawlessly. At this point, the aircraft was fully configured for an automatic landing in low visibility conditions. Everything appeared to be going according to plan. The jet remained stable on the glide slope, the Category 3 ILS mode successfully engaged and functioning normally. But at that very moment, the airline's operations center in Belgium abruptly changed its decision. They no longer wanted the aircraft to land at East Midlands, instead ordering a diversion to Liverpool Airport. After reaching their decision, the Operations Center immediately called East Midlands Tower, requesting air traffic control to relay the new instruction directly to the cockpit crew. At this moment, the crew was fully focused on the automatic landing procedure. But as the aircraft descended through 500 feet, one of the most critical phases of flight, the controller suddenly came over the radio, delivering the following message.
325 November, I've been instructed that you are not to land here, per your company's request. The decision to continue or go around is yours.
Both pilots heard the radio transmission, but only fragments of the message were clear. Making matters worse, the call came right as the first officer was running through the approach checklist. As a result, he completely missed the radio communication. The captain, having only caught a faint portion of the broadcast, could not be certain whether the message was intended for their flight. Seeing no response from the first officer, he decided to contact the tower himself. But at the very moment he tried to transmit, he accidentally pressed the wrong switch, disconnecting both autopilot systems at once and triggering a cockpit alarm. According to TNT's standard operating procedures, any autopilot malfunction below 1,000 feet requires an immediate go-around. Yet the captain did not initiate a go-around. Instead, he instinctively tried to re-engage the autopilot. This brought one system back online but left the other still disconnected, further confusing the aircraft's flight logic. At the same time, the captain's left hand remained on the control column, unconsciously applying a subtle leftward pressure. The aircraft's nose began to pitch slightly up, drifting off both the localizer and glide slope. The first officer noticed the autopilot had disengaged, but rather than calling for a go-around, he attempted to help the captain retune the instrument landing system signal.
We're too high. We need to descend.
At this moment, the aircraft was already below 500 feet, still approaching the runway at an excessive speed. The captain pushed the control column forward, causing the descent rate to surge dramatically, climbing from 650 feet per minute to nearly 1,500 feet per minute. Such a descent rate at this altitude was exceedingly dangerous. As the aircraft descended to around 200 feet, the control tower seemed to finally realize the severity of the situation and attempted to re-engage the approach mode, but it was already too late. Within seconds, the terrain warning system screamed, and through the windshield, the captain saw nothing but green grass ahead. He slammed the go-around button, desperately trying to initiate a recovery. Yet the aircraft was barely 60 feet above the ground, plummeting too fast to regain flight. The main landing gear hit first, striking flat grassland about 90 meters left of runway 27. The nose gear touched down briefly after, while the right main gear sank deep into soft soil, penetrating nearly 25 centimeters. The impact was fierce enough to tear the wing apart or ignite a fuel explosion. But at that very instant, two shear pins, just as designed, did their job. After the right landing gear sheared off, the aircraft veered violently to the right. The right engine scraped against the ground, and moments later, the right wingtip struck with a brutal impact. Yet, almost miraculously, the nose began to lift, raising the damaged landing gear clear of the earth. Inside the cockpit, the first officer realized the captain was no longer responding. He kept shouting, "Go around, go around." Sensing the crisis deepening, he took control without hesitation, pulling back on the yoke, pitching the nose up, and slamming the throttles to maximum power. Within seconds, the aircraft lifted off again. At that moment, the captain slowly regained consciousness and whispered, "I'll take the controls." The crew immediately began retracting the landing gear and flaps to optimize climb performance. But just as the landing gear started to retract, warning lights illuminated in the cockpit, indicating an unsafe gear status. This suggested that the gear might not be properly locked. The system, having detected the anomaly, automatically paused the retraction sequence to prevent aerodynamic imbalance or further mechanical failure. Meanwhile, in the control tower, dense fog made it impossible for controllers to see the runway. However, they clearly heard the roar of the engines and realized the aircraft was going around. The controller radioed, "Did you initiate the go-around because of my earlier instruction or due to weather?" The pilot replied, "We touched down. Please wait for company instructions." The tower did not immediately respond. A few seconds later, the crew proactively requested diversion to Liverpool Airport. ATC approved the request and instructed the aircraft to climb to 4,000 feet. Shortly afterward, the controller clarified that the previous message had come from the airline's operations center and he himself had not been fully informed of the situation. At 06:43 a.m., the captain declared a full emergency.
Quality 325 November. Mayday, mayday, mayday. We are experiencing a serious emergency. Request to maintain 3,000 feet. One landing gear is unsafe, flap malfunction, and only 3,000 kilograms of fuel remaining. Request vectors to the airport with the best weather conditions. Declaring full emergency.
At this moment, there was no doubt. The crew was facing a crisis, an emergency that kept escalating. During the East Midlands incident, the collapsing landing gear had ruptured the aircraft's hydraulic lines. This system was responsible for controlling several critical components of the plane. The rupture occurred above the hydraulic safety valve, causing a total loss of hydraulic pressure. As a result, the aircraft began consuming fuel at nearly twice the normal rate. In the cockpit, stress levels rose sharply. This was the second diversion attempt within a short span of time, yet they now had less than 40 minutes of fuel remaining. Worse still, the imbalance in the wing system caused the aircraft to list. Almost immediately, another warning appeared, a failure of the rear cargo door. It was one more technical fault piled on top of an already desperate emergency, turning the situation from critical to catastrophic. Realizing the severity, air traffic control instructed the aircraft to maintain altitude and guided it toward runway 15 at Birmingham Airport, where weather conditions were still suitable for landing. However, a new problem was about to emerge. At Birmingham Airport, the instrument landing system's glide slope component was out of service due to maintenance. This meant the ILS was incomplete. The captain immediately rejected both radar guidance and localizer-only approaches, judging them too risky under the current conditions. Instead, controllers directed the aircraft to runway 33, where the full instrument landing system was still operational. Although this required an additional 20 nautical miles of flying, it was considered the safer option in such a dire emergency. When controllers inquired about the landing gear status, a new plan was suggested. A nearby police helicopter would conduct a visual inspection. The helicopter closed in and confirmed. The nose gear and left main gear were both down and locked, but the right main gear was not visible. This matched the cockpit warning messages. The crew quickly completed their landing checklist and accepted final vectors, preparing for an emergency landing on runway 33.
40, 30, 20, 10.
The Boeing 737 touched down smoothly, veering slightly to the left to minimize the risk of collapse. With precise control, the captain kept the aircraft balanced until it came to a complete stop. After more than 3 hours of relentless pressure and cascading system failures, the crisis finally ended safely. In many respects, it was nothing short of a miraculous success. The final investigation report concluded that the incident was the result of multiple contributing factors. These included worse-than-forecast weather conditions, the captain's limited experience, particularly as this was his first time acting as pilot in command during a Category 3 blind landing combined with a complex diversion, and in the final critical stages of approach, an unexpected company directive relayed through air traffic control. It was this sudden radio message that disrupted the pilot's concentration, leading the captain to inadvertently disengage the autopilot, a mistake that triggered the irreversible deterioration of the situation. The report highlighted a critical lesson. Below 1,000 feet, the moment autopilot is disengaged, the crew must immediately initiate a go-around. This is a clearly defined requirement within TNT Airways' standard operating procedures. As the monitoring first officer, one must firmly call for a go-around, rather than attempting to help the captain recover an approach that has already become unstable and is no longer safe. Although the report did not issue a large number of new safety recommendations, it strongly emphasized that TNT Airways should further clarify its operational standards. Any crew member, regardless of seniority, has both the right and the responsibility to immediately initiate a go-around whenever there is doubt about flight safety.